Every Boeing space project explained, starting with the Starliner, Boeing's bold attempt to reclaim its place among the stars. It was supposed to be simple, a sleek, reusable capsule built to ferry astronauts to the International Space Station. Boeing, the same company that helped send humans to the moon, was finally returning to crewed spaceflight. The project, named CST-100 Starliner, was born under NASA's Commercial Crew Program, with a massive $4.2 billion contract and one mission to prove Boeing could still deliver. But the road was anything but smooth. In 2019, the first test flight ended in embarrassment when a software glitch threw off the spacecraft's timing, leaving it stranded in the wrong orbit. Engineers went back to the drawing board. 3 years later, in 2022, a second test flight finally reached the ISS. Redemption, at least for a moment. Then came 2024. 2 astronauts aboard Starliner approached the station when the thrusters began to fail. Mission control fell silent. After tense hours, the capsule docked, barely. NASA later decided not to risk bringing the crew home in Starliner. The spacecraft would return empty. Still, Boeing refuses to give up. The Starliner stands as both a symbol of resilience and a reminder that even the most experienced names in aerospace can stumble when venturing into new frontiers. Long before the Starliner ever touched the sky, Boeing had already built the engines that took humanity to the moon. In the 1960s, during the height of the Cold War, NASA turned to Boeing with an impossible task: build the first stage of the Saturn V, the largest and most powerful rocket in history. Its mission: to lift the Apollo spacecraft beyond Earth's pole. Boeing's engineers in Huntsville, Alabama, designed the SIC stage, a 138-foot-tall behemoth powered by 5 F-1 engines, each producing 1.5 million pounds of thrust. Together, they unleashed more power than all the dams on the Mississippi River combined. When Apollo 11 thundered off the pad in 1969, it was Boeing's creation, the SIC, that carried humanity's first footsteps toward the moon. The massive structure had to withstand deafening vibrations, liquid oxygen colder than Antarctica, and heat that could melt steel. And Boeing didn't stop there. The company later built the lunar roving vehicle, the electric car astronauts drove across the moon's dusty surface. From the first ignition of Saturn V to the final tracks on the lunar soil, Boeing helped define the golden age of exploration. A legacy that still echoes through every rocket built today. When the Apollo missions ended, Boeing faced a new question: what comes after the moon? NASA had leftover rocket parts, massive Saturn stages built for missions that never launched. Instead of letting them gather dust, engineers turned them into something extraordinary. With Boeing's help, those colossal tanks became Skylab, America's very first space station. Launched in 1973, Skylab was a bold experiment, a laboratory, an observatory, and a home. All in orbit. Boeing's teams re-engineered fuel tanks into living quarters, installed solar arrays, and built the systems that kept astronauts alive for months in space. Inside that recycled rocket shell, humans learned what it truly meant to live beyond Earth. How to eat, sleep, and work in zero gravity. Skylab only flew 3 crewed missions, but its lessons shaped everything that came next, from the space shuttle to the International Space Station. By the late 1970s, America's dream of reusable spacecraft had taken shape, a machine that could launch like a rocket and return like an airplane. The Space Shuttle. At first, Boeing's role was indirect. The orbiters, Columbia, Challenger, Discovery, Atlantis, and Endeavour, were built by Rockwell International. But when Boeing later acquired Rockwell's aerospace division in the 1990s, it inherited one of the most complex engineering marvels in human history. Suddenly, Boeing wasn't just part of the shuttle program, it was responsible for it. The company took charge of maintaining, upgrading, and managing key systems, including the orbiter's structure, avionics, and software. The shuttle opened a new chapter for human spaceflight, deploying satellites, repairing the Hubble Space Telescope, and building the International Space Station piece by piece. But it was also a program marked by tragedy. After the Challenger and Columbia disasters, Boeing engineers helped redesign systems to improve safety and reliability. Each launch became a balance between risk and reward, a reminder that progress in space has never come without sacrifice. For 3 decades, the space shuttle was the beating heart of NASA's ambitions, and Boeing helped keep it alive. 200 miles above Earth, a cluster of shining metal modules drifts silently through the void. The International Space Station, humanity's most ambitious construction project in orbit. Since its first components launched in 1998, Boeing has been at its very core. As NASA's prime contractor, Boeing designed, built, and integrated much of the U.S. segment of the ISS. From pressurized modules and connecting nodes to the complex electrical and life support systems that keep astronauts alive. Its fingerprints are everywhere: harmony, tranquility, destiny. Names that sound poetic, but behind each is Boeing engineering, wiring, and structure. Every bolt, panel, and computer system is part of a delicate choreography that must work perfectly every second of every orbit. Boeing's teams on Earth have spent decades supporting the station's maintenance and upgrades, ensuring it can host experiments that study everything from human biology to quantum physics. The ISS isn't just a lab, it's a symbol of international unity, built by rival nations who once competed in the Cold War. And at its center stands Boeing, a quiet constant in the background, holding the structure together as humanity's home among the stars. While astronauts explored the heavens, Boeing was quietly mastering the art of getting them and everything else there. The Delta rocket family began as a humble missile design in the 1960s. But under Boeing's guidance, it evolved into one of the most reliable launch systems in history. The Delta II, first launched in 1989, became legendary, carrying NASA's Mars rovers, GPS satellites, and countless scientific payloads into orbit with near-perfect precision. Then came the heavy lifters, Delta III and Delta IV, massive, hydrogen-fueled rockets built for military and deep space missions. Boeing's innovation helped redefine American launch capability. In 2006, Boeing joined forces with Lockheed Martin to create United Launch Alliance, or ULA, a partnership that would continue launching USDEFENS, NASA, and commercial payloads for the next generation. From planetary probes to national security satellites, Boeing's rockets became the invisible backbone of America's presence in space. Half a century after Saturn V roared to life, Boeing was once again asked to build a rocket powerful enough to carry humans beyond Earth's grasp. The mission this time wasn't just the moon, it was deep space. The result is NASA's Space Launch System, or SLS, the most powerful rocket since Apollo. And at its heart lies Boeing's creation, the core stage, a towering orange giant that burns liquid hydrogen and oxygen through 4 reused Space Shuttle main engines. Standing taller than a 30-story building, the SLS channels 8.8 million pounds of thrust at liftoff, enough to hurl the Orion spacecraft toward lunar orbit. Its design merges the lessons of the past with the technology of the future, combining Saturn's brute strength with shuttle-era precision. When Artemis I launched in 2022, lighting up the night sky over Florida, Boeing's core stage was the first to awaken, a thunderous reminder of what American engineering could still achieve. For Boeing, the SLS isn't just another rocket, it's a resurrection of a legacy, a return to the age when human exploration was measured not in miles, but in courage. Boeing's story in space isn't over, it's entering a new orbit. As NASA turns its eyes back toward the moon, Boeing is once again at the table. The company is helping design parts of the Lunar Gateway, a small space station that will orbit the moon like a cosmic outpost. Unlike the International Space Station, which circles Earth every 90 minutes, the Gateway will follow an elongated orbit around the moon, allowing crews to stay for weeks at a time. It will serve as a staging point for astronauts preparing to land on the lunar surface, and later, for missions venturing toward Mars. Boeing engineers are working on the habitation and logistics outposts and structural systems for future modules, leveraging decades of experience from the ISS. The goal is clear: create a sustainable, modular architecture that allows astronauts to live and work safely in deep space. Beyond the Gateway, Boeing is also developing concepts for deep space habitats, self-contained living environments that could sustain crews on journeys lasting months or even years. These habitats combine Boeing's ISS technology, environmental control, radiation shielding, power management, and autonomous systems. with cutting-edge research on human health and microgravity. Each prototype brings humanity one step closer to building permanent homes beyond Earth's orbit. But Boeing's greatest challenge today isn't only technical, it's cultural. In an era dominated by fast-moving private companies like SpaceX and Blue Origin, Boeing must prove that its heritage and precision engineering can still compete with the agility of newer players. The company's recent struggles with the Starliner spacecraft and delays in the Space Launch System have drawn scrutiny, yet Boeing continues to deliver key components that keep NASA's long-term exploration goals alive. At its heart, Boeing remains a cornerstone of America's space infrastructure, providing flight systems, avionics, and integration expertise that few others can match. While younger companies race ahead with innovation, Boeing carries the weight of legacy, the know-how that helped humanity take its very first steps off Earth. The future of human exploration will be built by many hands, new and old, private and public. And Boeing, with all its triumphs and scars, still intends to be one of them. Do you believe Boeing still has what it takes to lead us beyond Earth once again? Share your thoughts in the comments.